Hello and welcome back. So in the last two sessions, we managed to install the MariaDB 10.5 and followed by on the last video we did a replication setup between the two nodes, and we saw how simple that process really is. We're just creating a single user and setting the change master command on the replica node to point to the primary server that we want to point using that new user account, and just by telling which Gidi ID to use for your as a start replication position. So simple. And then we were able to set the replication up, and then we also managed to test some of the queries and some of the replication things, created a new table, executed some queries and all that stuff. So it's a very simple process. So now the final video of this mini series is basically setting up your MaxScale server. So I'm just going to fire this VM up very quickly and minimize it, let it boot up. Okay, so it's able to boot up now. So I'm going to split this one, not really here, maybe split here. All right, so just increase this a little bit and increase the font size a little bit more, and this one is going to point to 770. Yes, and I'm into the MaxScale node. So I've already installed MaxScale. So MaxScale is again very simple. So if you go to the MariaDB.com and just simple MariaDB MaxScale, you can download the latest one, whichever is available right now is 10.4.10, and again just select the OS that you want to download to, and yeah, that's it. It's just one single RPM. Just yum install MaxScale, this particular RPM file name, and that's all there is. All right, okay. So when you install MaxScale, you can basically check not gram, it should be grep MaxScale, and there is so I already have 10.4.10 installed on this server. And then of course with MaxScale you need to configure your MaxScale config file. It's by default is etc maxscale.cnf file, right? So I already have a template here, some data is already there. So I started working on this setup before we started the video. So yeah, so I've already configured two servers here. You'll see the MaxScale section is basically the default or the first section where we define the number of threads, and of course some detail related to the log file and all that. So if you just go to the MariaDB knowledge base for MaxScale, you can get all the details that there are, all the parameters or variables that can be configured and how to configure that. All that stuff is available there, but for this case we'll just keep it very simple. So threads auto, meaning it will basically depend on how many CPUs are available on your machine. MaxScale will basically use those many CPUs according to the availability. But of course if you want to limit it, you can always say maybe one. I just want to give it one CPU and not more than that. But yeah, I just leave it as auto. And then you would need to define your servers. So how do you define servers? Is very simple. Just within these square braces, give it a server name. Then this name is basically whatever you want to call that server. So I'm just calling it as primary. So within square brackets, give the name without any spaces. So this is my primary server, and then the type is server. So I'm defining the type as server. So this section is always going to be the same, right? So just keep that in mind. So these four parameters are always going to be there. You don't need any more than that, just for the setup that we are going to do now. So type is server, address is your IP address. This server is basically at which IP address, that is that. And then of course the port, if you are using a non-standard port or if you are using a standard port, still we need to give that port parameter there. And then the backend protocol, we need to define that this server is going to use which backend protocol. Um, so that's going to be MariaDB backend protocol. And then same goes for the other setup, other server. My other server name is given as replica. Again, you can give whatever name you want. So I have given replica. Then again, those 3 or 4 parameters are the same. Just of course, this the IP address is different. That's all. And then once you have the server defined, so you can have a lot of servers defined here, and then you can use them by, or you can access them by these names, right? So then we have we need to define a monitor, and this monitor is type of a module. Again, these names, whatever names in the square brackets, are up to you, whatever you want to call them, but just keep them consistent and something that makes sense. So that's why the server name I have just given as primary and replica, and this section I've given it as by the name as MariaDB monitor, right? So because it's going to be the monitor, the type is monitor, and the module is going to use MariaDB monitor. So let's say if you are configuring this MaxScale on a Galera server or a Galera architecture, then the module name will be Galeramon, G-A-L-E-R-A-M-O-N, Galeramon. You can go to the MariaDB MaxScale knowledge base, and then you will see what are the monitors available and all that stuff. So we have a monitor for MariaDB, which is this one, MariaDB Mon, and then you have a Galeramon for Galera, and then you have I believe you have one for Clusterix DB, and then you have one for column store, CSMon for column store monitor. So yeah, so these two, once these two are defined, then we need to define what are the servers that we want this monitor to monitor actually, right? So under the server section, we basically just give the 2 names, this is primary and replica. So like I mentioned earlier, once these servers are defined, we can access those servers by their name. Whatever name we used to define them, we can access them by that name. So that's what we are doing here. So let's say you have 10 servers, but you only want 2 servers to be monitored. You don't want the others to be monitored, is fine also. So you can just give the name of the 2 servers here in the monitor section. And then then we will need to give a username, meaning which user, because MaxScale will need to connect to the backend server or to the MariaDB server with a specific user account. So that user account needs to be created on the primary server, because we have replication setup already there. So that user account will be replicated over without any issues. So in this case, I have just given it as a max user. This user I haven't created yet. We will create that in a while. And then we have this monitor interval. So this monitor interval means that this is like a heartbeat, right? So MaxScale will, and this is defined in milliseconds. So 2500 millisecond, meaning 2.5 seconds. So every 2.5 seconds, MaxScale will use this user account to ping the 2 machines, right? Whatever defined in the monitor will ping those 2 machines, and then see what is the status of the master and the slave, right? So if everything is going well, or if one of the servers is offline, or one of these servers is trying to join back the cluster, and things like that. Just ignore this for now. This parameter says that we want to enforce read-only slaves, right? So which means that the master is going to be read and write, but the slaves, all the replica nodes, all the slave node will be enforced as read only, meaning you cannot, if you are using a non-root user account or non-super user account, you will not be able to do some transaction on the slave, which is what we want. So we don't want anybody doing any stuff or any business on the slave nodes directly. So we want everybody to be accessing these servers through MaxScale, right? So no direct connections. That's a bad idea. Unless you really know what you're doing, then it's fine. But for general usage and for everybody else, they should be going in through MaxScale server to the backend databases. So that is enforcing read-only slave nodes. And then you will see that these are probably the most important ones. So we are saying that MaxScale, or this monitor, should be the one doing the automatic failover. Auto failover true, which means that if your primary server goes down, which is the 71 node, if this server goes down, MariaDB should MaxScale should automatically promote the other guy or the other server as the new master or the new primary server. So this is super important for high availability, so that's what this does. And similarly, auto rejoin. So what happens that after maybe an hour or so, somebody fixed the issue on the node, and then we managed to start this server up. So what will happen then? So MaxScale will automatically join this node to the cluster or to the new master automatically. So without somebody doing anything, somebody just need to start this server up, and MaxScale will automatically run the change master command on this server to point it to this node now as a master, because previously this was pointing to this node. Now this node becomes the primary server, so this guy needs to connect to this node as a slave, and this will be the master. So that's something that MaxScale will automatically do using this auto rejoin and auto failover. And then the last part, or not really the last part, but the other service, or the last service in this section is basically read write service. You see this type is a service. The previous one was type is a monitor, but this particular section is a service type, and this is going to use the router as a read write split router. So this is a very super powerful router, which basically tells MaxScale that anybody trying to connect to MaxScale or to access the databases will go through this router, and basically these two servers are going to be the one where the traffic is going to be routed to, right? So if somebody, because this is a read and write service, and then the router name we are defined or we are using is read and write split router. So which means that when somebody connects to MaxScale to connect to the database, if they are sending a transaction or if they are sending a command that is going to do some DDL, right, create, drop, or alter, or maybe insert, update, delete, and something that is changing data or changing the database, that command MaxScale will automatically route to the master server or to the primary server, right? But if the client is just sending a select query, a read query, that query or that particular query will be sent to the slave node or to the replica node automatically. So this is kind of a load balancing act where MaxScale will help you, or will help us make use of the entire cluster. If you have, let's say you have one master and 4 slaves or 4 replicas, then MaxScale can probably make use of all those four nodes for read scaling. So MaxScale is basically helping scale our reads on multiple nodes, which is super cool. Again, we'll have to use a username here, because MaxScale internally will use a user to connect to these nodes for your read and write splitting. This user and this user needs to be separate accounts. So that's what I'm going to do now. I'm going to change this to maybe max monitor, and this one can be max user, and I don't have a password right now, right? So we need to create these 2 user accounts in the MariaDB server, max user and max monitor, with the specific grants that we want to have on this particular user account. And this read write split service is going to use these 2 nodes. Again, if you have 10 servers but you only want this read write splitting service going on between 2 or 3 nodes, so you just need to give those nodes here. You don't need to define all the nodes here, but generally it's a good idea to have all the nodes so that you can make use of the entire cluster. Similarly, some of the more useful parameters are master reconnection equals to true. So which means that if your backend goes offline, or if your master is dead and MaxScale promotes this node as a new master, so MaxScale should automatically reconnect to the new master, meaning all the connections that are there on the MaxScale through the client or from your client application, they would not have to they won't need to reconnect to the database, right? So they would automatically be redirected to the new master server. So that brings the high availability level of your application to very, very high. So probably the user wouldn't even notice that something happened in the backend, because their connection will automatically be routed or will automatically be moved to the new primary server by MaxScale. This one, ignore this one for now. This one we'll discuss later on. So transaction replay true, again, very powerful um, function of MaxScale 2.4 and 2.3. So this means that if, let's say, you are or the user is running through this read write service, if the user is running some transaction on the primary server and the primary server goes down, and maybe within a few seconds the other server or your replica becomes the new primary server or the new master. So what will happen is MaxScale will actually hold your transaction in memory, within its own memory, and then move it or replay that transaction. That's what this is. So your transaction will be replayed automatically on the new server. So your front end application or your front end clients will never even know what happened in the backend. So they would just see that their transaction was delayed for some time, for maybe a few seconds, the time that it takes for a new server to become a new master node, new primary node. So yeah, so that's what it is. So this will basically redirect your transaction or rerun your transaction, whatever was happening here while the server failed, it will be repeated on the other server automatically. So this is super awesome, which is not really available on many platforms right now. All right, so the slave selection criteria is adaptive routing. This adaptive routing is something new, that tells MaxScale to, if you have many servers available or many replicas available, because in this case we have only one, so it doesn't really matter much. But if, let's say, you have 4 or 5 replicas, then adaptive routing will basically check the response time from all the nodes. So whichever nodes is generally responding faster, your queries will be, or your read queries will be routed to that node. And once that node starts to get loaded a bit, your queries will be routed to the other node, whichever is responding faster than that particular node. So yeah, so it's a good way of distributing your transaction across your cluster. So yeah, so that's why I'm using adaptive routing here. And master accepts reads. So if this parameter is not defined, your master server will never get a read query. So your master will always, if let's say you want your master or you want your primary server to only serve writes, meaning only serve queries or transactions that are changing data, then you don't need to give this here. But if, let's say, you have a very small setup, like in my case I have only 2 nodes, so I want both of these nodes to be able to serve my read queries as well. So we can give this parameter like so. So in this case, if your query, if your other replica, if this replica is busy serving many other requests, your query will be routed to, or your select query will be routed to your primary node instead of the replica. So this way we are basically trying to maximize all the servers that are available in our cluster, right? So that's all there is for this service section for the read write router. Now is the most important one of them all, right? So now we have a service, we need to have a listener that this service uses, right? So that's what this particular section is. So this section, again, the name you can give anything that you want, and the type is a listener, and the service name, this listener is tied to which service is this service name. So this is important, this name should match with this service name. So that's what we are telling here, that this listener is actually tied to this particular service. So any connection that comes to this particular port, again, this port is your own choice, whatever you want to give, maybe 660 for example, or anything at all. So I'm just going to give as 4007. Yeah, so 407. So when I connect to MaxScale as a MariaDB server, so I would be using 4007 port in my command line. So that would tell MaxScale that since my connection is coming in through this port, this listener will be activated, or this listener is the one that is going to cache that connection. And this listener will know that whatever we are doing, whatever this connection is going to do, is going to go through this particular service, right? So, and all my activities are going to go through this particular setup, which is this primary, this replica, and is going to be doing a read write and splitting service. All right, so we are done with this explanation. I hope this clarifies all the things that there are, but of course there can be a lot other things, but we just have a very uh, essential setup that is the bare minimum requirement of for working MaxScale with a read-write split service. So now we need to create these two users account, right? So max monitor and of course the max user, max mon and max user for the read write service. So that's what we're going to do. This is my primary server. Create a user max one. So just for the sake of ease, I'm just going to give it as %, and meaning I'm just giving it as a wildcard, so this guy can come in from any other server or any IP address. I don't really care for now. Identified by, again, a very secure password. Password, oops, typo, oops, yeah, this gets irritating. Okay, so go back and put a single quote here, semicolon here. So my user account is created, and I'm going to do the same thing for the max user as well. So I have these two users created. All right. Now there is a specific set of grants or specific minimum grants that are required for the max monitor service, because this monitor is the one that is going to be able to control replication and all that stuff. But for now, just for the sake of this video, I'm going to give it all privileges just to keep it very simple. But I would add in more details in the video description of what exactly are those grants that are required. So I'll just say grant all on star or star to maxmon at person. So I'm just going to give all the grants that are available. Max user, not a good idea for production environment or any other production implementation. Of course, we should be following the very minimum requirements or minimum grants that are required for this function to work. So all is certainly not one of them. I think there are 4 or 5 grants that I don't really remember as of now, but I would put in those details in the video description. All right. Anyways, so the purpose of this video is to have a MaxScale working and listening to connections and routing your queries between the two nodes, and also handling the database failover and all that great stuff. All right, so we have this maxmon and max user already created and with a set of grants. So now what we are going to do here is we are going to define the password again. We are keeping this password in open text, which is not a good idea for any production environment. Again, there is a way to secure your passwords that also I will add in some more details, or maybe I would add another video or create another video on this particular section on how to secure your MaxScale config file. But for now, we will just put the password as it is. So we are telling that this user needs to use this password to connect to the backend database. Same thing goes for this max monitor as well. All right. I'm going to save and exit this file, and the file is saved. So let's restart MaxScale. Restart MaxScale, and MaxScale has restarted without any issues. So generally the log file for the MaxScale will sit under /var log MaxScale and MaxScale.log, right? So just remember that var log MaxScale and MaxScale.log. And yes, so now we can see that maybe let me move this a little bit over here so we can see the line. All right, so we can already see that it's in the log is showing that primary is the master, and 192.168.56.71 is the new master, which is running is in master running mode, and then this one is also running in a slave running mode. So meaning we have this master and slave running already. Let's do a very quick check on that. So there is a command for MaxScale, maxctrl list servers. Alrighty, so we have the primary and a replica. These again, if you remember, these are based on the names of the servers that we defined in the maxscale.cnf file. So we have this primary replica, that is this IP, this port, currently 0 connection because there's nobody connected to this server through MaxScale, so that's why there are 0 connections here. And this one is showing as master running, and this one is showing as slave running, and their current Gidi ID is 13, which we can verify from a slave status here. And there it is. So we can clearly see that MaxScale knows about the Gidi ID on both the nodes. Now you will see that this guy is also using the same Gidi ID 1013. Why is that? This one should be showing 2013, right? But no, because we have a primary replica setup or master slave setup, so your replica will always follow the master's Gidi ID, which is this number. So that's how you will know that this slave is pointing to, or this particular node is pointing to which server as a master. So that's something to take note of. So don't get confused when you see 1000 here. So this means that both of the nodes are in complete sync. Right, so I'm going to do something here, watch minus n1. So I'm just going to run this through watch, and we can see that the lines have disappeared, but that's an issue with the watch command, so don't really worry about that. But anyway, we can see that this master and this slave and this Gidi ID and this Gidi ID over here. So I am going to go to let's say we have this insert command, right? So I'm going to insert that command, that I'm going to execute that command one more time on the table tab, and just monitor this side. So whenever we execute something, MaxScale knows the current Gidi ID and it will constantly show us the current Gidi ID for each node. Let's say I'm going to quit from here. I'm going to stop this node. So my slave is down due to some power failure. My slave went down, or my replica went down, but of course because my master is still available, so people continue to run new transaction on that node. So now you see my replica is sitting at 22 and my primary is basically running ahead. Right, so my primary node is already gone way ahead. But if let's say after some time somebody fixes the issue and bring the server up, you will see that it will immediately try to catch up. Yeah, there it is. So it's already in sync to that Gidi ID. So that's how powerful this replication really is. But of course, if your database design is not perfect, is not good, so you can face some replication lags. So one of the rule of the thumb is to always make sure that all your tables have a primary key or a unique index. At least a unique index is available, because that's super important for a fast replication process. Right, okay, so this is done. Okay, so we will do one more thing. Now let's say of course we also want to see the failover, right? So I'm going to maybe give it some space here, and I'm going to connect to the MaxScale server. Right, so I'm going to tail my MaxScale logs. Okay, so just increase the size a little bit so that we see what's going on here. Yeah, there you go. Now we can see that it's the last status showing us these two are now running as master and slave. All right, so I'm going to do stop MariaDB. So keep this in your view and just see what happens over here. So it's down. MaxScale will capture that immediately, that master is down, right? So it has captured that. and it will immediately kick off the failover process. And now you will see that now the replica has been turned into a master now, right? And this guy is down, and that's what it shows here. The slave running has been changed to master running. Yeah, so there you have it. So failover primary to replica performed. So that's what you will see in your MaxScale logs, that whenever a successful failover happens, or if let's say due to some reason your failover did not succeed because of some other issues, there can be many problems, of course, but if that didn't happen, then you will also see those details here, and you will also see why the failover is not successful, and then you will have to fix that issue and to retry the failover. You can do the failover manually as well. There's a max controller command for that as well. But yeah, you can look for the MariaDB knowledge base for MaxScale for all those commands and whatnot. So now let's say I am now connected to the master. To this was my slave previously. Remember, I was running the show slave status command here. So now this show slave status doesn't tell anything at all. Because why? Because now this is the primary node. This is no longer the slave. So now I can do all that from here. Use testdb, and then maybe I will just say delete from tab, right? So I'm just going to do a very stupid thing, delete data from a table without a where clause, and then I lost 68,000 transactions, and then we see that my Gidi ID increased to 40, right? So this node has an additional transaction now. All right, so now I am going to start this server, because eventually we will have to start this server. So somebody fix the issue, is going to start this server back up. You will see it goes into running mode and then running slave. So, and then you will see that the transaction synced up very quickly from here to here. Now this guy is no longer the primary server. So this guy, whenever a primary node goes down, and then you fix that issue and start the server up eventually, that server or that node will always join as a replica, or as a slave or a replica. It can never join as a primary server or as a master server, right? So that's something to keep note. Why is that? Because your new master or your new primary server may be very, very far ahead in terms of global transaction ID, because if it's a busy server, it may be far ahead. So the node that is lagging behind cannot join back as a master for sure, because it needs to do a lot of catch up first. So once the data is in sync, then that node can become a new master. All right, so we can do that. For that that was supposed to be a separate video or separate topic, but why not? So if you yeah, so there it is. So you have this maxctl command. Maxctl is a command line for MaxScale, so that you use to you see that here maxctl list servers. We are running that here constantly using the watch. So maxctl has a lot of other options, a lot of other commands that you can run. So one of the command is to be able to do a switchover. So we are saying that we want to max controller, we are telling max controller to call this command for the MariaDB monitor. You remember we had a monitor called MariaDB monitor, and the monitor name is we defined in the maxscale.cnf as MariaDB mon, right? So this name should match with your MariaDB monitor. Let's say before even do that, let's do a list services. So the easier way to see what are the monitors available or what are the services available, just do a maxctl list services, and you will see that I have this this service here, and it's a router, and it's listening to this primary and replica service, right? So this is the name that we want to use in this maxctl command. So this MariaDB monitor is not really here. So this, we should be looking at list monitors. Yeah, there it is. So MariaDB monitor is the one that we want to use here, that name, right? Okay, so let's do that very quickly. So we are telling So how this goes is that we need to give the name of the new master first. So my first master or my new master should be primary now, right? So we want to switch over from this replica to the primary, and my current master is this one, right? So this is how the order goes. So I want to do a switch over to this node from this node, right? So that's a very simple thing to do, and it gives a OK, and you will see here the master flip to that guy now. There you go. So very simple, very easy. All right, so yeah, so another new thing for you guys, how to do a manual failover or manual switchover. You can also do a failover by stopping this server, meaning we can always do a stop systemctl stop MariaDB here. It should automatically flip to the other side. But if you have multiple servers, it can become difficult to get to the server where you want to go. So best is to just simply run, just simply use the max controller and call command to do a switchover from your old replica or old master to the new master, whichever you want to be. All right. Okay, so everything looks good for now. I think one thing remaining would be to see how we can connect to yeah, how we can connect to the databases through MaxScale interface. Because remember, we have this etc/maxscale.cnf. Yeah, so this listener we defined as using the port 4007, right? So that's what we're going to do. I think I already installed the MariaDB client here on this MaxScale server as well, but this is just for our testing. But generally you would have another client, like for example Heidi SQL or things like that. Okay, maybe let's do that. Let's download Heidi SQL. Yeah, so I am just going to download I don't want to download the installer, but I want to download the portable version. Yeah, portable version. That's super easy and super useful. So let me pause this video and then we will continue once the download is done. Alrighty, so the download is done. So I have this 11.0.64 portable version available here. So let's extract it to this particular folder. It's a very lightweight client and works really well. So let's connect to this guy. Okay, so we have this interface now. But before we do that, let's create a new user account. So which is my master, and my primary server is 71. Okay, okay, so create user. Maybe I'm going to create a user for application purpose, app user, at % again, just for the sake of keeping this simple, identified by another very secret password. Right. Okay, so we are going to create a I think we already have a database here. Oops, I think I'm too tired. Yeah, so we have a test database. Okay, so let's grant on that database only. Grant all on testdb.star. So we don't want it to have access to everything. We just want it to be able to do whatever it wants on the test database only, right? So app user at %. Oops, 2. Yeah, of course, I am really tired, so this confirms it. All right, so so we have this app user created now that has access to be able to access test database and all the tables within that database, right? So let's do a very quick connection. We know this user account, we know its password, and of course we know the MaxScale's IP address. All right, so the difference here is Instead of connecting to your master server or the slave server, we would be connecting to the MaxScale server now. So our MaxScale server is 192.168.56.70, right? And my username is going to be happy user, and my password is going to be my super secret password. But now I cannot use this port. You know why? Because my MaxScale is configured to listen to only this particular port. Of course, if you want, you can have multiple services, multiple listeners, or multiple read-write services listening to a different set of servers and listening to a different port. So the only thing you need to do is when you create a new listener with a new name, this service name needs to be the different name pointing to the different service, right? So this way you can have multiple pairs of read-write services and read-write listeners with different ports for every single service. But in this case, we have only one service available and one listener available, and that listener is supposed to be 4007. All right, so let's try to connect to 3306. It's going to use MySQL. I don't think there is a MariaDB here, but MySQL should work just fine. This is the name. I can give it anything, but let's save it for now, and we'll try to open. It would not open. Yeah, it doesn't open unless we want to connect to 71 with app user and 3306. That would certainly open up. Yeah, so we can see information schema, we can see test database here, right? So we are able to connect to the database directly, but not to the MaxScale server. So what we need to do, instead, we will need to use the MaxScale IP, and of course, you're right, 4007 for the read-write listener port. And I'm going to save this one more time and open up. And there you go. I can indeed connect to the database using that 4007. And now you will see something cool here. We have number of connections as 1. So meaning we have one guy connected to MaxScale, and then you will see that one connection is now connected to both backend server in a single shot, right? So you don't need to make two different connections to the databases. You may have 20 servers in the backend, so you don't need to worry about the backend complexity and all that. So your MaxScale should be able to know based on the configurations that you do here in the MaxScale.cnf file, this setup, MaxScale should be able to know what lies beneath, and MaxScale is basically providing you an abstraction layer against your backend complexity. So you just simply connect to MaxScale on a particular port that is defined for a particular service, and MaxScale will take care of the rest, right? So now you can see that we have one connection that is connected to all the database through MaxScale server. This one probably I want to disconnect, and yeah, now we can see the host name is for 192.168.56 and 70, right? So if I run a query here, select host name, right? So because this is a select query, I expect this query or this host name to return the host name for this guy, the current slave or the current replica, because this connection is going to the read-write split service, right? And read-write split service by default is going to redirect this. One thing I forgot, I'm not sure whether you guys are able to see the output. Okay, now it should be readable. Okay, so I'm doing a select @ this is a global variable host name. So if I run this command now, right, so we are currently within the test database. If I do a select star from tab, okay, I forgot, I already deleted everything from that table. So let's do let's insert into tab and C1, and for the values I am going to insert host name. You're right. So now this statement, because this statement is going to be changing some data on the server, so we expect even if I run a million times, even if I run this insert statement a million times, that should always run on the primary server, meaning whichever is the master, it will always run on that particular node. So I'm just going to go here. You just keep this Gidi ID also in view. So let's say run once, twice, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I executed it 20 times. Let's say select start from tab a few times. So I make it weekly section. So now it's still different. I'm going to a few times and select start is always do that. It will switch between the P and the P. Basically a split, right? Or it's basically doing a load balancing act. So what happens if I insert some data, insert into maybe tab C1, select, what if I do this, right? So insert into tab C1 and I want to run a select state. We know that if we run this in the state, it have C1 right? We go execute this statement on different servers because of the load balancing side. But when as soon as this statement comes within the scope of a statement that is changing the data, it will also be running on the master server all the time, every single time. So let's say truncate table tab, I'm just going to 1 3 5 7 9 10. Let's see, every single insert is basically 71. There's not a single 72 here. All right, so I think that confirms it. Let's see if I can open up another Heidi SQL session. Open up another one. Yeah, okay. So we still have the same setup here with the same app user and app password on this particular port. So if I open up another one, you see what happens here on this connection. There you go. So now we have two different users connected to MaxScale, and the MaxScale is connected to the two backend nodes for those two connections. So two connections from the front end to MaxScale will get MaxScale to basically open up and handle 4 connections on the two backend server, meaning 2 on each server, of course. So altogether 4 connections are being handled. All right, so now while we have these connections going on, what happens if my primary server goes down? Stop MariaDB. So you see my primary server goes down, the connection becomes 0. This is slave, still slave, and it's showing as 2 connections. It should be promoted as a master anytime soon now. Yeah, there it is. So it's promoted as a master. So if I go here, normally what would happen, that this would start to throw error message when I run a statement. Now this insert statement, this was originally in the older MaxScale version like 2.2, and before that it would show an error message saying that the backend is no longer available, or the connection is no longer available. But thanks to our configuration here, where we say that we want to be able to reconnect, and then the transaction replay this should automatically be reconnected to the new backend server. Yeah, I mean that there is now a update statement now, and I don't get any failures at all. So now if I run my select start from tab, so let's do select hostname. It would be easier to see. Hostname. Yeah, somehow it doesn't go to the node or no. All right, not sure why. We'll have to check. But what we can do for sure is to basically stop this node, and then it will flip the master to the other guy. Yeah, so we have a master available now, and I'm going to start this server again. So it's going to join as a slave. Alrighty. So if I run this command now, select hostname, and now it's running on one and two more than, so it's back now here. All right. So hope you guys enjoyed this. It was a long video, but I think we learned a lot, and I hope you guys can make use of this knowledge and have some easier time setting up MaxScale and the MariaDB replication on your environments, right? So thank you guys and enjoy.